Okay, good morning everyone and welcome to today's tutorial. For today's tutorials, we'll be discussing another physical topology, but today we'll be talking about the ring topology. So when we are talking about the ring topology here today, we will be looking at the physical ring topology. At the same time, we'll be discussing about the logical ring topology. So let me remind you that when we are talking about the physical ring topology, we are looking at how computers are connected. And when we are talking about the logical ring topology, we are looking at how data is transmitted on the ring topology. So with that in mind, we have our physical ring topology on the screen, and we can see there that the only thing that we can look and come out with is that each computer is connected to the next and the previous one. So that is the ring topology. Each computer is connected to the previous and the next computer, and at the end, the shape that we are going to receive is a ring. So that is the ring topology. In the ring topology, each computer is directly connected to the next and the previous computer within the same network. So that is what we need to know about the physical ring. Physically, each computer is connected to two computers, and at the end, the shape that we receive is a ring. So now with that in mind, we are now going to look at how data is transmitted on the ring topology. For that reason, we have PC1 that has built a packet destined for PC4. PC1 has built a hello packet that is destined to PC number 4. So since this piece of data is not for PC2 and PC3, how are they going to react according to this piece of data? Because the data does not belong to them, it's for PC4. And another question is how is PC4 going to recognize that this piece of data is mine? So it's the same question that we asked when we were dealing with the ring topology. The only thing here is that when PC1 is going to build this hello packet that he has built, you can see it, that is a hello packet. After building that hello packet, the PC1 is going to address that hello packet to PC number 4. So it will put the address of PC4 on the hello packet. So the question now is, how is that data going to travel from PC1 to PC number 4? So that is, you can see the piece of data leaving PC1, getting to PC2, going to PC3, and at the end getting to PC number 4. And you can see that PC number 4 has read the data, and you can see it on the screen of PC number 4. The hello packet has been received by PC number 4. Now what you can also see on PC number 2 and 3 is that when the packet is reaching those PC, the only thing they are doing is to check again the address on the piece of data, and after checking they will realize that no, this is not my address, or this is not our address, and they will forward the packet up until the packet will reach PC number 4. So in this topology, you can see that the moment one computer is building up a piece of data or information for another computer, the data is going to travel across all the devices on the network up until it reaches the destination. But the difference between the ring topology and the bus topology is that when a computer receives a piece of data that does not belong to that computer, the computer does not drop the packet. Instead, the computer will forward the packet to the next computer. But contrary to the bus topology, when they receive that piece of data that does not belong to them, they drop it immediately. But in this case, you can see PC1 built that packet and sent it across the network. The packet got to PC2. PC2 will look at the packet and say, okay, this address does not belong to me. It will forward it to the PC number 3. PC number 3 will again check the packet and say that, oh, this packet is not mine. It will forward it up until the packet will reach PC number 4. And when it gets to PC number 4, PC number 4 will look at the address on the packet and say, okay, this is my information, and definitely will receive the piece of information sent by PC number 1. You can see the transmission end up at PC number 4. It doesn't go back to PC number 1 because PC number 4 was the destination of the packet, and when it gets there, PC number 4 reception the packet. So again, when we talk about the ring topology, we see a topology where each computer is directly connected to the next and the previous computer within the same network, and at the end we get a form of a ring. So that is what you have physically, and have explained the logical part of it already. Now, what are the advantages and the disadvantages of a ring topology? The first thing is that when we talk about a ring topology, there is a strong signal. Why are we talking about a strong signal in this case? If you check again, each computer here is assisting in regenerating the traffic. So that is a reason why we are having a strong signal. This is because each computer is responsible for generating the signal. So the packet sent by PC1 got generated by PC2, and the same time got generated by PC number 3 up until the packet got to the destination. That is why we have a strong signal. The next advantage is that it is moderately easy to install as compared to the mesh topology. The ring topology is a little bit easier to install as compared to the mesh topology. Now, what are the disadvantages that we need to know about the ring topology? The first disadvantage that we need to know is that any device on that network represents a single point of failure. Not only a device, even the cable. If you take, for instance, PC number 1 offline, the system is down. There is no connection anymore. All the system would be down. If a cable breaks, the system is down. That is the reason why we are saying any failed system on the network, including cable breakage, represent a single point of failure. That is the greatest disadvantage of a ring topology. Any device on the network represents a single point of failure. If one device fails, the whole network is down. Another disadvantage is that whenever you are adding or removing a system or a device on the network, definitely that will cause the network to go down, because there's no way you can add a device or remove a device without disconnecting the cable. So any adding or removing devices from the network will cause the network to go down. Now, the last thing that you need to know about the ring topology is that ring topology is an active topology. Remember, when we were dealing with the bus topology, we said it was a passive topology. Passive because there is no device on the network that generates the signal. So when they receive any signal that does not belong to them, they drop it. But with the ring topology, it is an active topology. This is because any signal sent by a PC, when the PC receives that signal, it regenerates the signal and send it across the network. So ring topology is an active topology. Devices on the network regenerate signals and are responsible for moving data from one device to the next one. So that is how it works on the ring topology, and it is really the opposite of a bus topology, where a device does not move data from one computer to another, but here the device moves data from one computer to another. And to explain that, you can see PC1 has sent a piece of information. The information was received by PC2. PC2 forwarded the information to PC3, and PC3 forwarded the information to PC4. That is the reason why we said they are responsible for moving information from one computer to another. So that is the particularity about the ring topology. I hope this is being informative to you, and I would like to say thank you. See you on our next tutorial, which will be about the mesh topology. Thank you for watching. Goodbye.